My name is Carl Anthony, and I work in the automotive industry in Detroit. Sometimes that work encompasses future vehicle technology, and that's what we talk about here, for the most part anyway. This is AutoVision News Radio. From childhood computers and electric roller skates to machine learning and next-generation ADAS innovations, Florian Baumann believes in the big-picture value of technology, especially machine learning, and its ability to create safer roads and more efficient transportation systems. Florian is the Senior Director of Product Management, Middleware and DevOps at Aptiv. Aptiv is a global technology company focused on safer, greener, and more connected solutions to empower a more sustainable future of mobility. As our guest on AutoVision News Radio, Florian shared his early experiences with technology, his studies at university, and how machine learning can be leveraged to save time, reduce costs, and improve overall efficiency. Florian provided us with an overview of Aptiv and his role with the company.
So Aptiv is a multinational company developing solutions for the automotive industry. It's one of the classical tier ones, similar to Bosch and Continental and Magna and Valeo. Aptiv is having their domain expertise in developing automotive solutions such as advanced driver assistance systems, traffic sign recognition systems, autonomous emergency braking systems. So systems that are based on radar data, camera data, LiDAR data, or sensor fusion. So we are heading into a direction of so-called software-defined vehicles, and that all the different functionalities that we have as of today in the vehicle are represented by a software function. The brain is the computer that's taking decisions around where the vehicle is driving, and the nervous systems are all the different cables and connectors in the vehicle itself. And I am responsible to identify technologies in terms of software and hardware for the next generation of software-defined vehicles. So what's coming up in 7 to 10 years? How does the next in-vehicle and cloud architecture look like? Are there any interesting technologies coming from startups or from universities or from other commercial parties that we would like to adopt into our solutions? So it's a forward-looking focused role around next generation architecture, software and hardware.
Sometimes the things we experience as kids resonate into adulthood. I still have, a collection of Hot Wheels and Matchbox cars. Probably why I grew up to eventually work in the automotive industry. And likewise, Florian's introduction to technology came at an early age.
This is going back to an age that I was 6 years old. I got my first computer, a personal computer, as a present from my father, and I started to disconnect the hard disk, and finally I damaged it. This is a story. And I also got my first electronics playground. This is a small system that you can get if you are 5 or 6 years and older, with a lot of resistance and batteries and small LEDs. And I was playing around with it. So I got obsessed with technology early on. It was 8 or 10 years. I built some electrified scooters, electrified roller skates, and radio-controlled helicopters and airplanes.
Right.
And programmed them, built them, destroyed them, built them up again. So I was in touch with technology early on. Then I decided to study electrical engineering. And during my 4th year, I started to work and started to publish papers and started to work in an academic institution focused on science projects. And I started to get in touch with machine learning. So I built one of the very first real-time face detection algorithms during that time on an iPad or on an iPhone, detecting faces. And I was highly fascinated about machine learning, how you can teach a computer to learn things. And after working 2 years as a student in this institute, I made somehow the first baby steps for my PhD thesis. And after finalizing and completing my study, I already had 3 or 4 publications out there in the area of machine learning, face detection, object detection. And I started to tackle the next challenge around human action recognition. So trying to detect movements and human actions in a series of images, I was, and I still am, I'm highly fascinated of how to teach a computer to learn by implementing an algorithm, collecting data, tweaking and tuning the data, pre-processing the data, learning a system, trying to understand this system, and then to see this system in operation on an edge device.
When you connect with Florian on LinkedIn, you will see written in his bio what can be described as one of the key benefits of machine learning. I'll read verbatim now from Florian's LinkedIn profile. In the automotive industry today, the focus for most companies is on creating a consolidated data structure, getting their cloud strategy and data management right. Once those steps are taken, we can start applying machine learning to improve efficiency and save costs. I asked Florian to take me through that and to help me get my mind around this concept.
Yes, this is a very good question. In order to train these machine learning algorithms, and I was talking about human action recognition or object detection earlier, you need a lot of data. Data must come from different sensors, like a camera, a radar, a LiDAR, or a motion sensor. So the better the quality is of your data, the better your algorithm is. Collecting data is expensive, and collecting data is also very challenging, especially in the automotive industry. You have to build up prototypes, and you have to send out these prototype vehicles to many different countries in the world. And you have to collect data under many different conditions, such as environmental conditions, illumination conditions, weather conditions on different highways, under different speed ranges. You have to also capture specific corner cases and edge scenarios, such as an unprotected left turn is not happening every day. That somebody slides in front of you on the highway is also not happening every day. So you have to cover all these different variations. In order to tackle this challenge of driving in millions of kilometers and petabytes of data, you would require an end-to-end data processing toolchain, because this data has to move through a lot of different steps. You have to record the data, you have to pre-process the data, you have to ingest the data into the data center, then you have to prepare the data again, then you have to curate the data, because you would like to understand what is the quality of the data that I was driving in, because typically you are not interested in scenarios such as driving 4 hours behind a truck. You are interested in corner cases and these edge scenarios, and this is what you have to identify. Then very often you have to extract context information out of the data, and then you have to label the data. Labeling means that you have to draw bounding boxes around all the objects that the algorithm should detect. If you are implementing an algorithm that detects vehicles, you have to train this system with hundreds, thousands of small vehicles under all these different conditions that I was talking about. Rainy conditions, cloudy conditions, a vehicle from the left, a BMW, a Mercedes, a convertible, a truck. All these different vehicles are the ones that you need to train the algorithm. So you have to label the data. You have to get a bunch of people in front of the data who are drawing bounding boxes around the data. You have to store the meta information in a database somewhere. You have to store the sensor data in your data center. After the data got annotated and labeled, you have to train your machine learning algorithm. Then, after you've trained your machine learning algorithm, you have to measure its performance. So you need a training data set and a test data set, and you have to measure the performance of your algorithm under all these different variations. If this fails, and it fails very often, you have to restart the whole process again. So sending out vehicles, driving in exactly these scenarios that are missing or that the performance of the algorithm is not good in, and you have to restart everything again. This is an end-to-end, very complex data processing tool chain that you would require. If you are having this end-to-end data processing tool chain and that all these steps are connected with each other without manual intervention, you can develop much faster and cheaper because the whole process is fully automated. And this is why I'm having this in my LinkedIn profile, because it's so important to have this available.
With the continued movement toward software-defined cars, Florian illustrated how there are two sides to the coin.
I'm always taking the big tech companies as an example, the Google, Apple, and Facebooks of the world. These companies are highly agile companies who can move much faster than a classical automotive OEM. But this is also a bit dangerous, this statement, because they do not deal with functional safety requirements. An automotive can kill a person, and you can get killed because of a malfunction in your vehicle. So the requirements around functional safety are much higher. And this is maybe also representing one of the challenges automotive industry is adopting to these agile software-led cultures, but it's a longer process.
Florian is serving as the chairperson for the 2023 ICA Summit. ICA stands for Innovation, Connectivity, and Autonomous. The 2023 event will engage the industry on these topics and more through individual presentations, panel discussions, and expositions. I've had the occasion to work with the organizers of the ICA Summit. They do a tremendous job. They've put together an incredible agenda. And as the third edition of the annual event, the 2023 ICA Summit will explore how manufacturers, suppliers, and other solution providers are validating connected vehicle technology, what the future may hold for autonomy, and why regulatory frameworks must be considered. The event is set for May 15th and 16th in Frankfurt, Germany. As the chairperson, Florian will guide attendees throughout the event and encourage open dialogue during Q&A segments.
For example, if one company is speaking about cybersecurity and another company is also speaking about cybersecurity to try to identify the synergies between these presentations and to formulate them in a lessons learned session. I'm also responsible to network, so to connect different companies to each other in order for them to benefit from this. And then to create finally a great event for the audience and the speaker itself.
As a parting thought, Florian shared the importance of reducing the complexity of the in-vehicle EE architecture.
In a premium vehicle, we are having more than 100 ECUs. The complexity is increasing from vehicle generation to vehicle generation. We have to react and we have to reduce the vehicle's complexity of the EE architecture by, for example, breaking down the amount of ECUs that are required. So we have to move over into so-called zonal architectures. This is an area that Aptiv is prominently placed. You could check out Aptiv's smart vehicle architecture that we've presented. This is the future, and this is a significant trend that I'm seeing in the industry.
To learn more about the Aptiv Smart Vehicle Architecture, visit aptiv.com. That's aptiv.com. More information on the annual ICA Summit is available at ica-summit.com. That's ica-summit.com. In Detroit, alongside Florian Baumann, I'm Carl Anthony, AutoVision News Radio.